comes to doing these trig problems, first thing we want to is make sure we've got two different situations we're dealing with. We're dealing mainly with the right triangle trigonometry, SOHCAHTOA. So I always want to check to see if I have a right triangle or not, if I have that right angle. Because if I do, then we want to dive right into identifying my sides and setting up my SOHCAHTOA. If we don't, it's going to be law of sines or law of cosines. Okay? But most of what we're going to do is going to be the SOHCAHTOA. So, like we've talked about before, the first thing we want to do whenever we're dealing with this is identify my sides by name. Which side is the opposite? Which side is the adjacent? Which side is the hypotenuse? So that's almost always going to be our first step. So if I look at these triangles, the hypotenuse is always the easiest one to spot because that's the one across from the right angle. Okay, so on these first four problems, those are my hypotenuses. Okay? Easy to spot the hypotenuse. Stop playing with your calculator. So your eyes are up here. Okay? Okay? So we identify our hypotenuse. Next we want to identify our opposite side, which again, this is the Greek letter theta. That's just our angle of reference. You don't need to know the name of the letter. That's just like x. It's just a different symbol other than an x. It's a Greek letter. So that's our opposite side is always across from that. Notice that my opposite side is on the left a couple times. It's on the top once. It's on the right once. It has nothing to do with left, right, top, bottom. It has everything to do with its relationship to the angle that we're working on. Okay? So that's how we determine opposite. And of course, if I have two sides, the third side must be the adjacent. So we've identified our sides. Now for these first problems, don't overdo it. Okay? We're looking for identification of what is the ratio of tangent for that triangle. Now we have our SOHCAHTOA. And that tells us which sides go with which function. The S in SO stands for sine. The C in co stands for cosine. The T in TOA stands for tangent. So I know it's sine, cosine, or tangent. O stands for opposite, H stands for hypotenuse, A stands for adjacent. So it wants a tangent of theta. So tangent is opposite over adjacent. So my opposite here is 16. My adjacent is 12, and I reduce that fraction. And that's my answer. That's it. I'm not solving for the unknown angle here. If I was, I'd have to use an inverse function to do that, but I'm not. I just want the ratio and reduce more. That's my final answer. Cosine is adjacent over hypotenuse. So the adjacent we identified as 9. The hypotenuse is 15, so that's 9 over 15, which is 3/5 reduced. Sine here is opposite over hypotenuse, or 7 over 17 root 2. Now, most of your calculators are going to handle just fine simplifying that. You could use your fraction key, 7 divided by 17 root 2, and hit equals, and it will give you your simplified fraction. Yours will not. Okay? If you get stuck on something like that on the test, leave your answer as 7 over 17 root 2. If you just gave me the right ratio, but you just didn't simplify it, you're going to get most of the points. You're just not going to get that last little half point yourself for simplifying. All right? Or if you know how to simplify it, that's fine. Just multiply by root 2 over root 2. That's 7 root 2 over 34. Like I say, most of you put 7 root 2 over 17 in your calculator, and then you get the equal sign. It'll do it for you. Okay? I don't know if I gave you any on the test that actually are that hard. I think most of them are pretty straightforward, kind of like this one here. Tangent is opposite over adjacent, or 7 over 24. That doesn't even reduce. That's just exactly what it is. And we're going to continue to do this. We're going to continue to identify our sides to start with. Here's theta, so there's my hypotenuse. That's the opposite. This is the adjacent. I'm at the cosine, which is the adjacent over hypotenuse, or 12 over 13. Here's this triangle, so this is my hypotenuse. This is my opposite. This is my adjacent. Tangent is opposite over adjacent, so that's 12 over 16, which reduces to 3/4. So that's how we just set those first problems up. And our first problems tomorrow are going to be the same way. You don't have to solve the angle, you don't have to solve for x, you're just setting it up. Then we get into the solving problems. The solving problems, we basically start out the same way by identifying our sides. Okay? This is my angle, my 68. The right angle's here, so this is my hypotenuse, right? So we go across from the right angle is the hypotenuse. Okay? Across from the angle of interest, that's going to be our opposite. So this is my opposite. And then the third side must be the adjacent. Awesome. Now here, we have to do a little bit more detective work, because now we aren't told which function, we have to figure out which function. But again, SOHCAHTOA is in play. So we still have SOHCAHTOA. And we can see on this particular triangle that the sides involved are the adjacent and the hypotenuse. The opposite has no x by it, has no number by it, it's just not being used. So, adjacent hypotenuse. The adjacent shows up here and here. The hypotenuse shows up here and here. The one that has the adjacent and the hypotenuse is CAH, C-A-H, cosine. Put your phone away. Okay? So cosine is the function we're going to use here. Oops, I didn't want that. So for this problem 7 here, it's going to be cosine of the angle equals the adjacent over the hypotenuse. Same thing we've been doing all along. Our equation is going to set up this way all the time. Sine, cosine, or tangent, pick the function of the angle equals the ratio. Now, my variable this time is in the denominator. Sometimes my variable will be in the numerator. Sometimes my variable will be the angle. Each one has its own different way of solving it. When the variable's in the denominator like this, the technique we've been using is this. We swap the values. So x is 12 divided by cos 68. And that's, then we just, and once you've got that far, now we just punch in our calculator and we're done. So 12 divided by cos 68 is what, 22.0? 32, sorry, glasses, 32.0. Okay. Next problem. Again, same thing. Identify the parts being used. The hypotenuse is being used. The opposite is being used. Opposite hypotenuse, that's the sine function. Sine of the angle equals the opposite over the hypotenuse. We set up our equation. This time the x is in the numerator, so we aren't going to swap things. That happens when x is in the denominator. When x is in the numerator like this, we simply multiply through both sides by 10, which cancels out my 10 there. So x equals 10 times sine 47, which is 7 point. Okay. Regarding the 32.0, some people are like, well, what if I just put 32 for that answer? that's probably okay. The only downside of that is that if someone is reading your work and they don't know what you're doing, they may think you just rounded the nearest whole number instead of rounded to the nearest tenth. By seeing 32.0, I know it's somewhere between 29.5 and 30.49. Okay? If I just see 32, now it's maybe between 29.95 and 30.04. If I just see 32, it's between 29.5 and 32.49. So there's a much bigger range of values it could possibly be, depending on how that's indicated. So the 0.0 indicates to the reader that you're rounding to the nearest tenth. So it does help. Okay? And we just keep doing the same thing. Okay? Identifying our sides. Hypotenuse, 57's here, so this is my opposite, so this is my adjacent. This is opposite adjacent. Which function uses opposite adjacent? Sine, cosine, or tangent? Tangent, yep. Tangent of the angle equals the opposite over the adjacent. Multiply both sides by 5. 5 tan 57 is 7.7. Again, hypotenuse, opposite, adjacent. This is the hypotenuse and the opposite, so which function is that? Sine. Sine of the angle equals the opposite over the hypotenuse. We multiply both sides by 16. And I get that that is 7.0. Okay, just keep doing those same things with right triangles, which most of our test is. Oh dear, there's a theta thing there again. That's fine, that's fine. We keep doing the same thing. It's still a right triangle. We still start by identifying a part. I see that right angle, I'm going to go, which side is the opposite, which side is the adjacent, which side is the hypotenuse? First thing I want to know. So hypotenuse, angles here, so this is the opposite, this is the adjacent. We still have the same thing. Which sides are involved? The opposite and the adjacent are. Opposite and adjacent is tan. So tangent of my angle, and if you don't like the letter theta, the Greek letter theta, you could make it x, it's fine, or tangent of A would be good too, equals the opposite over the adjacent. Now, I don't multiply through by 7 this time. That's not going to help me. I don't swap because that's not going to help me. The angle's unknown. When the angle's unknown, we solve by using what? The inverse function. Yes. So my angle, theta, is the tangent inverse of 2.6 over 7, which we do in our calculator. When we do that in our calculator, we come up with 20.4 degrees. I heard a huh. Okay, do you know how to do that in your calculator? Second function tangent?
Yeah.
Of the ratio. Okay? So this next one, again, right triangle. Gosh, let's start by identifying the sides. That's the hypotenuse, opposite, adjacent. Opposite and hypotenuse, which function? Which function's opposite hypotenuse? Sine. Sine of the angle is the opposite over the hypotenuse. This is just like what we set up in the very first part, isn't it? Okay? Now I don't need to reduce this. Don't worry about reducing it. We only reduce it if it's a final answer. It's not our final answer. So we use the inverse function. So theta is the sine inverse of 4 over 6. Which, if I put that in my calculator, we come up with about 41.8 degrees. Okay? Remember, when the angle is unknown, we use the inverse function to find the angle. Okay? When a side is unknown, we use just the regular function. The inverse function gets used when we don't know the angle. That might be something people write in their notes. Couple more examples here. Hypotenuse, opposite, adjacent. Hypotenuse and adjacent. Which function is hypotenuse and adjacent? Cosine. Okay. Tangent is opposite and adjacent. This is hypotenuse and adjacent. Okay. Hypotenuse adjacent is cosine, so cosine of theta is 9 over 14. So the cosine inverse of 9 over 14 is 50.0 degrees. Again, hypotenuse, opposite, adjacent, cosine again. Cosine, of theta, I was jumping, equals adjacent over hypotenuse. So the cosine inverse of, put that in my calculator, is 48.8 degrees. So it didn't matter if the variable was at the angle, if the variable was in the numerator or the variable was in the denominator, we set them up the same way. How we solve them once they're set up is different. But obviously knowing SOHCAHTOA and understanding which function goes with which sides, that's 90% of the battle. And to be honest, this test tends to go very well for people. People get that down, and once they get that down, this is a piece of cake. They slow down enough to identify the sides and have that big SOHCAHTOA written across the top. If you just keep referring back to it and are careful how you label your sides, it's hard to make mistakes. All right, now we don't have right angles anymore. So SOHCAHTOA is gone. Okay, I can't use SOHCAHTOA if there's not a right angle because SOHCAHTOA requires me to have a hypotenuse. No right angle, no hypotenuse. So here's law of sines and law of cosines. Now on the test, I give you a very subtle hint in the instructions. It'll say something like, use the law of sines to find the measure of angle A.
That's pretty simple.
It's as subtle as a sledgehammer. You'd be surprised how many people don't read the instructions. They look at the triangle and they try to figure it out. Okay? And so it'll say, use the law of sines to solve the triangle, and they'll use the law of cosines, or they'll use SOHCAHTOA. It's like, but I tried to be obvious. Okay? I'm not trying to trick you. I'm not trying to trick you. All right. Now, the only thing that is a little bit funky here is they say find AB. Well, AB here is this side, which we call side C in the law of sines. We call it side C. So that's fine. It's across from angle C. I'm always going to, when I set up my law of sines, put my variable I have to solve for first. Over, in this case, so that's a side, so over the sine of 47, and then that's going to be 17 over sine 56. Okay? So this time put sides on top, angles on bottom. The reason I do that is because it makes the next step much easier if the variable comes first. When I cross multiply sine 47 times 17, and then sine 56 times c, this diagonal up there stays put, the sine 56 winds up dividing right back down there. So I can save myself some time by just multiplying this up to here. So c is 17 sine 47 over sine 56. Okay? And as we learned yesterday, I have no objection to people chewing gum, but you've got to stop popping it. Or we'll just have no more gum. Because that's just really annoying. Okay? So we pop that in our calculator. Make sure you're closing the parentheses after sine 47. Okay? And yeah, I know that was your graphics. Okay? So close that parentheses. When we do so, we should come up with C is about 15.0. Now this one, we want to find AC, so I want to find this side, which we would call B because it's across from angle B. So B over sine 85 equals this side, C, over sine of C. Wait a minute, I don't know angle C. Well, I know two of the angles though, right? So if I know two angles, I can find that third angle. That third angle is going to have to be 43. 180 minus 85 minus 52 gives me 43. Cross multiply, B equals 13 sine 85 over sine 43. Pop that in my calculator, and I should come up with 19.0. Well, what if it's an angle that we're solving for? Well, it's not a problem. It works the same way. We're going to put our unknown first. So angle C is what we're looking for. And I don't put just angle C on top. I put sine of C on top over side C, which is 14, equals sine of 123 over 30. I have seen a couple people who are trying to drop the word sine there. If you don't put the word sine in there, it's not the law of sines anymore. Okay? It's not the measure of the angle versus the measure of the side. It's the value of the sine of that angle measure versus the length of the side. That is proportional. Okay? It's really important to realize that. Okay? C over 14 does not equal 123 over 30. That does not work. It's the sine of C over 14 equals the sine of 123 over 30. You have to have that sign there. It's called the law of sines for a reason. Again, we cross multiply. So sine C equals 14 sine 123 over 30. But when I put that in my calculator, uh, 14 sine 123, close the parentheses, divided by 30, I get 0.3914. Four decimal places. That's not my angle. You're right. It's not. That is the sine of the angle. When I know the value of sine of the angle, how do I find the angle? Inverse function, just like we did before, right? When I knew the ratio for sine, I use the inverse function to find the angle. Here I know the decimal value instead of the ratio. Same deal, we're going to use the inverse function. Second function sine of that value is 23.0 degrees. Okay, so literally I'm doing sine inverse equals 23.0 degrees. And that's the measure of angle C. So here, again, I want to find the measure of angle B, so sine of B over side B, 12, equals the sine of 136 over the side opposite that, which is 27. So sine of B is 12 sine 136 over 27 12 sine 136, close parentheses, divided by 27 is 0.3087. So now I do the sine inverse of that value, and I get 17.98, or right about 18 degrees. Okay? By the way, don't put the degree symbol in the computer. I said some people are trying to put the degree symbol in on the test. Don't just put the number. Don't put the degree symbol in. Number one, it's hard to find and do. It's not just for case. It messes everything up. It marks everything wrong automatically. Just put the number in to the nearest tenth. These will say yes.
So will it make you put in 23.0, or do you just put in 23?
I think I've got it. If it's a 0.0, I think I have it set up so that it will accept either answer. But even if it marks it wrong, I go back and check. And if it's supposed to be 23.0 and you put in 23, yeah, you're going to get all your points there. Okay? I do that. I mean, even if you had 23.1, I'm probably going to give it to you. I'm going to give you some wiggle room. Okay? But again, show your work, set up your problems, bring pencil and paper, bring your calculator tomorrow. You ready to organize? And by the way, as you're showing work, don't just scatter it all over a sheet of paper. Organize it. 1, 2, 3, 4. Okay? So I can find your work. Okay? It does make my life easier. All right, find BC. This is going to say use the law of cosines to find BC. Now, law of cosines is going to be easy for us. Okay? I'm finding this side right here, A. So A squared equals the other two sides squared added, 28.6 squared plus 14.2 squared, minus my law of cosines, 2 times these other two sides, times the cosine of the angle in between. That got long. Okay, we put that in our calculator. 28.6 squared. Put it in carefully. And we get 1129.833. Okay? You say, that doesn't make any sense. That's a stupid answer. I must have done something wrong. I must have put in the wrong numbers. What did I do? No, you did everything fine. That's not the length of the side. That's the length of the side squared. Right? Law of cosines always gives me the length of the side squared. So I have to take the square root of that answer to get the length of the side. The side is the square root of that, which is 33.6. Because that's a squared, not a. Just remember that little quirk about the law of cosines. It gives you the length squared. I gotta move this thing again. My little podium here is kind of crept too close to the smartboard. Or it's not a smartboard, it's, you get the idea. Because I need a little more space. They must move it when they clean. Okay. All right, this one. Again, same idea. This is my side we're going to get here, so c squared. Sorry, I'm going to run out of space here. So c squared is one side squared plus the other side squared minus 2 times each of the sides times the cosine of the angle in between. Again, that's going to give me c squared. When I take the square root of both sides, I should wind up with 39.8. Meters, technically, I guess there were some units there. You won't be responsible for units. Don't worry. Okay? And again, it'll be subtle, so use the law of cosines to. The multiple choice problems. Okay. Some people actually do these first because it helps orient them. But again, these are there because I want you to have practice working on ACT style questions, especially with you taking your Aspire test on Tuesday. We're back to right angles, so we're back to doing what first? Labeling sides. Hypotenuse. Theta's here. Opposite. Adjacent. The sides involved are the that was the wrong tool. But the opposite and the adjacent. Which function uses opposite adjacent? Tangent. So if tangent is our function, I know that's wrong, I know that's wrong, and I know that's wrong. Multiple choice is all about eliminating wrong choices until you find the right one, right? Okay? Tangent is opposite over adjacent, so the opposite is 10.8. This one has 10.8 on the top, this one has 10.8 on the bottom. Oh, the 10.8 has to be on the top. It's the only answer that makes any sense. Again, identify. Hypotenuse, opposite, adjacent. I'm using opposite hypotenuse. Which function? Sine, okay. Opposite over hypotenuse. The 10.6 has to be on the top. Ding, 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 ding. Thank you for playing the game. One more time, just for practice. Hypotenuse, opposite, adjacent. Opposite and hypotenuse are involved, so which function? Do not fall in the trap of, gee, the first one was a tangent, the second was a sine, this one has to be a cosine. No, it doesn't. It's sine again.
Let's go. I'm so smart. Not really.
Okay, opposite over hypotenuse, 2.2 over 6. Aha. That's the one I want, not that one. There. Now these require just a teeny bit more. We're actually going to set up our equation. But not a ton more. Again, label our sides. Hypotenuse, opposite, adjacent. Which function am I going to use here? Cosine, because adjacent hypotenuse are involved. So I'm going to write it. Cosine 39.4 is adjacent over hypotenuse. All right, first off, it's cosine, so we can eliminate all these sine and tangents. When I go to solve this, am I going to multiply both sides by 3.2, or am I going to swap the cosine to the bottom? Well, there's not this. I'm not going to swap it with 3.2 because there's no x down there. I'm going to multiply both sides by 3.2. So, C is my answer. So for these, it's usually best to like write out the equation and then pick the right answer. Again, hypotenuse, opposite, adjacent. This is going to be sine of 64 is 15 over x. Aha, so it's going to be a sine to start with. And it's going to be 15 divided by sine 64. I is my answer. By the way, you may notice this on ACT style tests where the choices are A, B, C, D, E, then E, F, G, H, I, and then back to A, B, C, D, E, and then E, F, G, H, I. The reason they do that is because if you're bubbling in the answers on a Scantron sheet, which you do in the ACT still, in the actual ACT you do that, it's to prevent you from accidentally getting one line off. It's real easy to do, like, you're answering question 13, but you're actually filling it in on 14. It's real easy for that to happen. Here, that makes it a little harder because my answer is I, and I go to my line and it's A, B, C, D, E. wait a minute. Where's I? Oh, I'm on the wrong line. Woo! Thank goodness. I almost skipped a line and that would have screwed up all my answers. Yeah.
So then if you go 2 lines down.
Yeah, then you're kind of done. But it should be obvious. It's kind of obvious on your answer sheet if you skip 2 lines. Skipping 1 line sometimes you can do and not catch that. Okay, because you'll look back and go, wait a minute. Okay, so it's designed to reduce that type of error. It's not going to eliminate it. It's going to reduce it. Which function am I going to use here? Somebody tell me which function.
Cosine.
Cosine, yes, because I have the hypotenuse is over here, the opposite is over here, the adjacent is here. So cosine of 62 is adjacent over hypotenuse. So this is going to be cosine. And the cosine 62 is going to be in the denominator, so there.
Let's go.
Okay, we're getting there. We're almost done.
Uh-oh. I don't like that.
Find the area.
That's an ugly triangle.
It is. I hand drew that one, sorry.
No, like the numbers are ugly.
No, they aren't. 14.2 and 12, it's not bad.
So
Because again, it's just, yeah.
would X be A then? If we're going off the thing right there on the board?
A, B, and C.
Yeah, like the formula right here on the whiteboard.
Oh, area.
Yeah, should we just put, oh, I'm talking about the next one.
Yeah.
This one?
Yeah. would
Yeah,
X-
the area, that's the area formula, 1/2 AB sin C.
So then it would be like the same thing, but it would be like half XY.
Half 14.2, half side times times the included sine of the included angle. I mean, literally, you'll have one problem like that. It'll be just like that. You just have to plug the numbers in the formula. Make sure you have the formula on your formula sheet. If not, it'll be on the board back there. Okay? And
No matter what order you go in.
no. Because it's all multiplication. 83.3. The nearest tenth is my area. So, yeah, if you did 12 times 14.2, that's fine.
To label it, you put it squared, right?
Units squared, yeah, but we aren't going to worry about units here. We'll worry about that when we get to chapter 11. All right, finally, a couple story problems.
Oh God, I hate these.
Maybe they hate you too.
Can we
Yeah,
not
they
do
probably
that?
do.
Can we not do these ones? We don't have to-
Sure, that makes it real easy for me to grade.
Okay.
Zeros are great.
Oh, that's lame.
Okay.
But it's a sacrifice.
Okay, guys, it's gonna be a right triangle, right? Guess what? We're gonna set up SOHCAHTOA on every one of these problems.
I'm gonna move it.
Okay, so you're not gonna get some weird shape here.
Great.
You're trying to find the tallest tree in the area. The current contrast is 74.8 feet high. You have what you think is a prime contender, so you decide to calculate the height. You walk 40 feet away from the base of the tree on level ground and measure an angle of elevation at the top at 62 degrees. Determine the height of the tree. Do you have a winner? Which number is not going to be in my triangle?
74.8.
Yeah, that's what we're comparing against to see if I have a winner. That's not part of my triangle. Okay? Gosh. Here I am. I'm looking at this big tree. Okay? I'm standing 40 feet away from the base. I'm looking up at the top of the tree. My angle is 62 degrees. This is considered a right triangle. How tall is the tree? That's just a plain old SOHCAHTOA problem, isn't it?
No.
Hypotenuse is here, x is the opposite, this is the adjacent. Tangent of 62 is opposite over adjacent. So 40 times tan 62 You wind up at 75.2 feet, and you got yourself a winner. Ding, 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 ding. This is a 40, by the way, not a 48. Again, I'm still not a fan of the Promethean board writing. 75.2. You're winning.
So if you put 75.2 divided by 40, would it be the same answer as 1062?
Yes. Forest rangers in a tower 120 feet above the forest floor. They notice smoke in an angled depression of 6 degrees. How far away is the source of this smoke? Okay, so they're up here. Angle of elevation depression has to be taken from the horizontal. So they look down 6 degrees. By the way, what's this side of, there's the right angle. Look, how long is this side over here? How high are they? 120 feet. How far away is the source of the smoke? Now granted, this is in the air, not on the ground, but it'd be the same triangle down here, right? It's a rectangle. So, tan of 6 is 120 over x, and you think that you wind up with 1141 feet.
I got 120.7.
Oh, I forgot.
Did you use 60 degrees or 6 degrees?
6.
Yeah, it looks like 60 here. 6 degrees.
Wait, what was that?
Yeah. Okay, I'll get that.
Let me look. 1141 to the nearest foot. Okay,
Wouldn't the nearest foot be 42?
maybe it is. I don't know.
Okay, you ready?
I'm going to give you the benefit of the doubt on that. Don't worry. Okay.
Oh, I'm stupid.
We got through it.
Can I go see Miss Ramsden now?
Wait.
You got 4 minutes. Go. Get
What?
yourself over.
If they're 120 feet above the ground, 120 be right there instead.
No, because no. It's going to be on this side of the triangle. Remember, this is going to be a long, skinny triangle going like that. Because you're taking your angle 6 degrees from a vertical line, the angle has to be from the horizontal. Angle of elevation, pressure, voice.
So what is it?
Horizontal.
What is it?
It's what you see right there. All right.